Now, another skill that you're expected to learn here within trigonometry is how to use one ratio to determine another ratio, and then to apply what you've found. So basically, what we've got here is a line between A and B, and an angle. That line makes that a horizontal. So we've got a horizontal, we've got our angle A, and we've got A and B. Now it tells us that tan of A is 1/3. And what we're asked to do, we're asked to find sine of A. So basically, we know that tan is TOA and sine is SO. We've got an opposite side length, but we need a hypotenuse. So what we do is we take this information, tan of A equals 1/3, so the opposite side length is 1, the adjacent side length is 3, so we've got 1 and 3. Now we want to work out our hypotenuse, because that's what we've got here. So to do that, our hypotenuse equals the square root of 3 squared plus 1 squared, and we end up with the square root of 10. So that's what we'll put here. So we've got the square root of 10. Now, because we've got the square root of 10, we now work out the sine of A. So we'd say that sine of A equals opposite over hypotenuse, and in this case, our opposite is 1, and the hypotenuse is root 10. And to rationalise that, it becomes root 10 over 10. So that's what we've got now. So we managed to find sine of an angle. Now, from there, we're asked to find out what the height would be if we had a length for A to B. So we're going to redraw that. Now it tells us we've got a length from A to B of the square root of 5. We've still got the same value there, we've still got the same angle, and it wants to work out how high above the horizontal it goes. So we're trying to work out that value there of x. Now, the trick is with this is we express what's going on here in terms of what we've got going on here. Now we've got enough information. We've got an opposite, now we've got a hypotenuse. So we can say that we've got sine of A equals x over root 5, based on this information here: opposite side length, hypotenuse, and our angle. Now, if that's what that equals, we also know that sine A equals something over here. Sine A equals root 10 over 10. So from there, we equate them. So we say, instead of sine A, we put down root 10 over 10 equals x over root 5. So we're going to multiply everything there by the square root of 5 to solve for x. So we'll have root 5 root 10 over 10 equals x. I'll simplify, so we've got the square root of 50, draw that clearer. Square root of 50 over 10 equals x. So the square root of 50 ends up being 5 root 2 over 10 equals x, and that's simplified to root 2 over 2 equals x. So for this, what we've got, we work out, so even if we're not given an angle, we can still find sine, cos and tan, as long as we've got one of the ratios. So if we're given tan ratio, we could find sine, we could also use it to find cos. So we determine the information we need, the side length, and from there we express that in the form of what we're interested in. Then we take what we found here, so sine of A, and we use it to solve when we're given a side length. And yes, that's an application of trigonometry and also ratios.